But today, we're moving on to something different, radical equations. And there is some considerations of, not cases so much, but as whether an answer makes sense. That's why we're kind of doing this here, because otherwise it's not really related to what we've been doing. But there is a little bit of that, but it's quite a bit more straightforward, and the steps to solving are quite a bit more straightforward. Does anybody have any thoughts on how we might solve this first one? Yeah. How are we going to do that, though? Because when stuff is in like a radical sign like that, I can't just break it apart. Some people might think this. Is the square root of x plus 4 the same as the square root of x, the square root of x plus the square root of 4? But that's not true. That would be similar to x plus 4 squared is equal to x squared plus 4 squared. And that's not true. We know that's not true. So radical signs, remember, are just exponents written a different way. So that's not true. Square both sides, beautiful. So that's all we're going to do. And when I square this, just briefly, okay, don't write this down, but the square root of 5 all squared, or actually let me do a better one. Square root of 25 all squared. I take the square root of 25, which is 5, and then I square it as 25, right? So it's 25. The square root of, let's do this one now, 5 squared. Well, I don't know what the square root of 5 is. This is going to be some nasty irrational number. But when I square it, I'll get back 5. So it's equal to 5. So we know, and this is definitely something you know from previous years, the square root of a all squared, or I can do a squared, square root of that, both equal a, right? So on the left side here, I get x plus 4, and on the right side, I get 9. Subtract 4 from both sides, x equals 5. See? I promised it was going to be easy. It's easy. In your head, does that answer make sense? Take 5, plug it in. 5 plus 4, what's that? Oh, that's 9. Square root of 9 is 3, equal to the right side. We're all good. Okay, B. So something that Jason said is going to help us here. Jason, remind me what you said. So in this case, we're going to do some of that work first. And this is just like solving a regular equation that you've been doing tons of. So I'm going to subtract 4 from both sides. And I get 2 square root of x minus 4. When you do your square root signs, folks, it is really important how you write them. Square root sign doesn't do this. Like if it's covering the whole thing, it has to cover the whole thing. And in some cases, the computer doesn't do this. But if I was writing something after, we call that a tail. You put a tail on it so it's obvious where it stops and where like the next part would start, right? So the 4 is in or out. You got to make that obvious. If there's any doubt, if I have to question it at all, or anybody reading your work has to question what you mean, that's your mistake in communication. That's what communication is all about, clarity. And then divide both sides by 2. And then what do? We square both sides. And now I add 4 to both sides. And again, I can do a quick left side, right side check. 13 minus 4 into the left side up there is 9. Square root of 9 is 3 times 2 is 6 plus 4 is 10. That's the right side. We're all good. I've mentioned this but we didn't do it as a formal process. Like we kind of did a couple of little times, but for the most part, we didn't do this as a formal process over the last several days. But folks, left side, right side check is an integral part of solving any kind of equation or inequality. So, you know, you should be in the habit of doing it, even if it's just anecdotally. Scrap paper, if you can do it in your head, great. On your calculator, that's fine. You don't have to show it to me. But why do we do that? In grade 9, when we start doing this, and in grade 10, it's often a part of the process. Like we force you to do it. Like your teachers tell you have to do it left side. Why? Because we just want you to see how important it is, right? And it helps us remind us what we're doing and that kind of thing. Same thing with this, with all of those inequalities that we were solving. It's a really good idea. I said this yesterday, to pick a value in the interval you're thinking of, plug it in and see what happens. Is it bigger than? Is it smaller than? Is it supposed to be? All that stuff, right? It really also just helps make connections and that sort of thing. Any questions? Let's keep going. Let's keep motoring. All right, so this one's pretty straightforward. Square both sides. -3 all squared is 9. Add 1 to both sides. X is 10. Awesome. Happy with that? Everybody okay with it? Don't see anything weird about it? So this is a bit of an interesting conversation. Well, no, but do you? Because when you take a square root, yeah, there's no plus minus. When you take a square root, we have 2 answers. How do we know which one? Are they just both okay? So they're not. In this case, we're talking about only the positive square roots. And this is, you can think of it as the idea of like a function. So let's do this. And what would this function be? You used to graph these in grade 11. So this is a shift to the right 1, and otherwise it's just a square root. When is that equal to -3? It's not. It's not either or. Okay? So this would be if there was a negative in front of that, and we were talking about that part of the function, then we'd be good. But in this case, this is not possible. We don't take a square root and get a negative. But the problem is when we square both sides, the negative disappears. So we wouldn't know it at that step. Does that make sense? Okay, so be careful of that. So let's do another little example here. If I subtract 7 from both sides, I get x plus 8 equals -5. Whoops, therefore, no solution. Yes. That's why I crossed it out. When you get, good question, you would have to show, you're not allowed to state no solution up here. And people love to do this. They love to look ahead. Oh, this is going to work out like that, so it has no solution. You got to show the work until it's clear that you've got to a step that's not going to work, and that's when you're allowed to say no solution. So you would have to do that first step, get to this line, and then you can say it. I probably won't give you a question quite that easy. If I did, you would just state no solution right off the bat. That make sense? And that's going to become even a little bit more clear when we do there's one more kind. They're a tiny little bit harder, but not much. One more kind of question that we're going to do a couple of examples of, and it'll be a bit more clear exactly what we're talking about when we do that. But again, we're thinking about these as a function. So it's not a plus minus square root. when you take the square root of something, you have to consider the plus and the minus. Typically speaking, when the square root's already written in like that, it just means one of them, either the positive or the negative, and it would have to say. This is kind of a math classroom problem, because in real life, you have to consider your situation in the context of what you're doing. But anyway, I don't want to discuss that too much. So this is where it becomes more clear that we have this bit of a problem. And what's different about this question? So I want you to look at it, look at the other 4 examples that we did, and see if you can see what's different. Man, what do you think? It has an x term outside of the radical. So if you look at the other 4, the x's were always under the radical. The expression under the radical sign, do you remember what the name of that is? Radicand. Okay, so the radicand had the x. We still have an x in the radicand, but we also have an x outside the radical. So that does make this question different. So what happens when I square both sides? So I get this. I get x plus 1 all squared equals x minus 5 all squared. So the left is going to be x plus 1, but the right is going to be, you don't have to write this out obviously, but this is what it's going to be, right? Remember, when you're squaring a binomial, we just talked about this, it's not x squared minus 5 squared. It's x squared minus 5 times itself. So I get x plus 1 equals x squared minus 10x plus 25. I'm going to subtract 1 from both sides, 1x, sorry. I'm going to keep my x squared term positive, and then subtract 1 from both sides. And what do we do now? Yeah, solve by factoring. This is just grade 10 question. It happens to be a quadratic. Okay. So algebraically, I'm trying to think of when, I don't think we've really done anything quite like this. Well, it's sort of the last few days, although it's a little bit different. But in grade 11, you do a lot of work with rational expressions. And that's our next unit, by the way. We get back into some of that rational expression stuff. But you're just doing a lot of algebra. You're moving stuff around. Remember, you like add rational expressions really hard because sometimes you factor, sometimes you expand common denominators. There's all kinds of crazy stuff you have to do there. And you have to state restrictions as you go. Remember that? Why do you have to do that, though? That's going to become really important next unit when we start working with it. It makes sense. People understand why you would state restrictions. But anyway, we'll get into it more in the next unit. But ultimately, something that happens in mathematics that's really important is we have all these skills that we can manipulate questions. Okay? And so I start with whatever my original expression was. Okay? And with all these awesome skills that we have, we end up getting something. Look at this line, I can solve it. Okay? And there's nothing wrong with what I've done here in these 2 steps to get here. But the problem is, because of all those skills we have, these answers still have to match the original equation. And because of the steps that we do, like squaring both sides of things, sometimes that that doesn't happen. Sometimes we get these perfectly valid algebraic answers, but they don't match the original function. That's what you call an extraneous answer. I don't know if you've ever used that word before in math class or had to, but those answers are called extraneous. So we've gotten these, an answer is extraneous if algebraically it works out, but it doesn't match your original question for some reason. And there are different reasons why that would happen. Okay? So the reason why I put little question marks in the equal signs is because I happen to know this is one of those. You don't have to do that. I like to do it, but you wouldn't have to do that. A lot of teachers wouldn't. But I happen to know this is one of those cases where I might have an extraneous answer. So I have to check them both, and we're going to do a formal check. You are going to show your left side, right side check here. We're just going to do a quick one. But you have to show and check because there's a good chance one of them will be extraneous. Not always, but there's a good chance. Often it happens. Okay, so I'm going to check if x equals 8. And again, I'm using that question mark because I'm not sure it equals 8. I'm checking if it equals 8. Not because I've made a mistake. That's why we do a left side, right side check in grade 9 or grade 10, in case we made a mistake. I'm not worried about that now. If the answer is extraneous and I made a mistake, I mean, I'm out of luck. Like, I'm not going to be able to find it anyway because it's extraneous. But so grade 9 and grade 10, we're doing it for a different reason. Here, we're checking if our answer makes sense or if it's extraneous. Okay, so the left side is the square root of 8 plus 1, which is the square root of 9, which is 3. And the right side is 8 minus 5, which is 3. Left side equals right side. Therefore, now I can make my statement x does equal 8. Now I'm going to check if x equals, what was my other answer? 3. Square root of 3 plus 1, which is 4. Square root of 4 is 2. Three minus 5, which is negative 2. X doesn't equal 3, it's extraneous. Sorry, 2. No, 3. Yeah. And x equals 8 is our only answer. Again, I would say you may want to be careful about your final summary statement. Make sure it's obvious what your answer is. In this case, we have one answer. Algebraically, the other one worked out. They match. What do you think? If, again, we were to graph both sides, it's not super interesting necessarily in this case. Let's see. Some of the cases get more interesting when the graphs are more complex. So x plus 1, that would be this graph. And x minus 5 would look something like this. So if I also had this graph, there's the other answer. Right? But we don't have both, we only have the positive. Okay, let's try one more. Sometimes when we think things are easy, we practice less, and then that ends up ruining us because it still can muddle up with other things that are more complex. Or, like I've said this before, you get a little bit anxious when you start writing on test day, your nerves fire a little bit, and then all of a sudden things drop out of your head. I'm sure lots of people have experienced that. So more preparation, even if something's easy, it's still worth practicing so you become an expert. Then you can do it without thinking. You'll always remember it. For the final exam, you'll remember it, right? And I could imagine that even a question like this is one that could cause somebody issues if they forget that you have to move the x over to the other side. Okay, and from here I'm going to square both sides. So this is going to be 64 minus 16x plus x squared. Now I'm going to rearrange. I'm going to try to make sure my x squared stays positive. So I'm going to have 0 on my left. Negative 16x minus 1x is negative 17x. And 64 plus 6 is 70. Go ahead and factor that. It's big numbers, but sometimes people I remember in grade 10, this is a question that some people would actually have a hard time with. Like, holy cow, 70, that's got a lot of factors. Well, the answer is actually obvious if you just think about it for a second. So see if you can figure out. Seven and 10. Okay, now go ahead and do the check. Okay, so there you go. So I got my check for 7 worked out. My check for 10 did not. Notice you don't always get like positive 2 and negative 2, depending on how the original question is structured. You just get left side doesn't equal right side. So that's what I meant by it's not an obvious check of whether or not it works. You could dig a little deeper and think about it and see why, but that's the method, essentially. And then I will remind you, we're still thinking about this as like 2 graphs that meet. That still can be a very useful thing. So if I have a square root function, what are the different possibilities I could have? when it meets a line. It could never meet that line. I could get no answer. What would that look like? I could get the one that we've seen where you get one and the other's extraneous. Or I could get two if it cut through like that, right? So you can get all of them. So you can't take it for granted. Don't expect always one's not going to work. Don't expect always one will work. Like, you gotta do the full check and see what happens. So there is still that, like I said, that little test of, we got these answers, but do they fit? Do they make sense? We have to think about them a little bit. Any questions?